Welcome everyone. I am Dr.V.Sulochana, Assistant Professor, Department of Mathematics, Sitalakshmi Ramaswamy College, Trichy. In this presentation, I am going to discuss the K-D mean labeling of some disconnected graphs. Overview of this presentation. This presentation consists of the definitions for the graph labeling and the graphs used for this labeling. And the results obtained for those graphs are stated as theorems. And we have the illustration for those results. At last, we have the conclusion. Graph labeling. A graph labeling is an assignment of integers to the vertices or edges or both subject to certain conditions. If the domain of the mapping is a set of vertices, then the labeling is called a vertex labeling. And if the domain of the mapping is a set of edges, then the labeling is called an edge labeling. By a PQ graph G, we mean a graph G with the vertex set and edge set, and the cardinality of the vertex set is given as P, and the cardinality of the edge set is denoted as Q. Let us see the definition for mean labeling of the graph. A P, Q graph G is said to have a mean labeling if there is an injective function f from the vertices of G to the set of elements 0, 1, 2, etc. Q such that the induced map f star defined on E by f star of uv equal to ceiling of f of u plus f of v by 2 is a bijection from the edge set to the set of elements 1, 2, etc. Q. A graph that admits a mean labeling is called a mean graph. In the similar way, we define the K-D mean labeling of the graph. A P-Q graph G is said to have a K-D mean labeling if there is an injective function f from the vertices of G to the set of elements 0, 1, 2, etc. up to k plus q minus 1 into D, such that the induced map f star defined on E by f star of uv equal to ceiling of f of u plus f of v by 2 is a bijection from the edge set to the set of elements k, k plus d, k plus 2d, etc. up to k plus q minus 1 into D. A graph that admits a K-D mean labeling is called a K-D mean graph. The observations are every K-1 mean labeling is a K-mean labeling and every 1,1 mean labeling is a mean labeling. For this discussion, we have considered two graphs. One is comb graph and another one is bi-star graph. A comb graph Pn plus is a tree attained from a path by attaching exactly one pendant edge to each vertex of the path. And for the bi-star graph, Bm, N is a tree obtained by joining the center vertices of the copies of K1, M and K1, N with an edge. First result, the graph PM union Pn plus is a K, D mean graph for all K and D greater than or equal to 2. So the vertex set for PM union Pn plus consists of the elements Ui from 1 to M, Vi and Vi dash from 1 to N, and the edge set of PM union Pn plus consists of the elements Ui plus 1 from 1 to M minus 1, and Vi plus 1 from 1 to N minus 1, and Vi dash from 1 to N. This is the ordinary labeling for the graph PM union Pn plus. So for the result, we have two cases. First case, when M is odd and N is even, or when M and N both odd, we label the vertices as follows. F of ui equal to k plus d into I minus 1 when I is odd, and k plus d into I minus 2 when I is even, and f of 1 equal to k plus m minus 1 into d plus 1, f of v1 dash equal to k plus m minus 1 into d minus 2, f of v2 equal to k plus m plus 1 into d minus 1, f of v2 dash equal to k plus m plus 1 into d, f of vi equal to k plus d into 2i plus m minus 3 for 3 less than or equal to I less than or equal to n, and f of vi dash equal to k plus d into 2i plus m minus 3 minus 1 for 3 less than or equal to I less than or equal to 1. For case 2, when m is even and n is odd, or when m and n both even, we label the vertices as f of ui equal to k plus d into I minus 1 when I is odd, and k plus d into I minus 2 when I is even. f of bi equal to k plus d into 2i plus m minus 3 when 1 less than or equal to I less than or equal to n, and f of bi dash equal to k plus d into 2i plus m minus 3 minus 1 when 1 less than or equal to I less than or equal to n. When we apply these labeling to the vertices, the induced edge labels are f star of ui plus 1 equal to k plus d into I minus 1 when 1 less than or equal to I less than or equal to m minus 1, and f star of vi plus 1 equal to k plus d into 2i plus m minus 2 when 1 less than or equal to I less than or equal to n minus 1, and f star of vi dash equal to k plus d into 2i plus m minus 3 when 1 less than or equal to I less than or equal to n. So this labeling provides the k comma d mean labeling for the graph PM union Pn plus. For all the four cases, we have the illustration here. So this is the illustration for 10, 2 mean labeling of P5 union P8 plus. So first we label the vertices as 9, 10, 13, 14, 17, 16, 19, 22, 21, 25, 26, 29, 30, 33, 34, 37, 38, 47, 42 and 45, 46. Then the induced edge labels are, so starting from 10, so we have the k value as 10 and the d value as 2. So starting from 10, we have the edge labels at a distance 2 apart. 10, 12, 14, 16, 18, 20 up to 46. So 46 is nothing but the value k plus q minus 1 into d. So this is the second illustration. Next illustration for P3 union P5 plus. And 8, 10 mean labeling of P4 union P5 plus. 4, 20 mean labeling of P6 union P4 plus. So next result is the graph PM plus union Pn plus is a k comma d mean graph for all k and d greater than or equal to 2. So we have considered the union of two comb graphs here. So the vertex set of Pm plus union Pn plus consists of the elements ui dash from 1 to m and vi dash from 1 to n, and the edge set of Pm plus union Pn plus consists of the elements ui plus 1 from 1 to m minus 1 and ui dash from 1 to m, vi plus 1 from 1 to n minus 1, vi dash from 1 to n. So this is the ordinary labeling for the graph Pm plus union Pn plus. So these are the labelings we have obtained for the vertices as well as the edges. So this labeling provides a k comma d mean labeling for the graph Pm plus union Pn plus. So this is the illustration for 22, 2 mean labeling of P6 plus union P12 plus. So next result, the graph Bn, n union Bn, n is a k, d mean graph for all k and d greater than or equal to 2. So this is the graph obtained from the union of two bistar graphs. So this is the vertex set and edge set, and the ordinary labeling of the graph are given here. And this is the vertex labeling and the edge labels. So these labels provide the k, d mean labeling for the graph Bn, n union Bn, n. So this is the illustration for 7, 2 mean labeling of B6, 6 union B6, 6. So starting from 7, we have the values for the edges as 7, 9, 11, 13, 15, 17, etc. up to 57. So next graph, Bn, n union Pn plus. So the union of the bistar graph and the comb graph is also a k, d mean graph for all k and d greater than or equal to 2. So this is the vertex and edge set of the graph and the ordinary labeling for the graph. So vertex labeling and the edge labels are given here. So this labeling provides the k, d mean labeling for the graph Bn, n union Pn plus. So this is the illustration 3, 10 mean labeling of B6, 6 union P6 plus. Conclusion, as every graph is not a k, d mean graph, it is very interesting to investigate graph or graph families which admits k, d mean labeling. In this presentation, k, d mean labeling for some disconnected graphs are discussed. For the better understanding of the proofs of the theorems, labeling pattern defined in each theorem is demonstrated by the illustration. Thank you, everyone. Let us see with a new topic in the next presentation.